Okay, and we are live. Okay, yeah, so welcome to our electrical lesson part 2. Let me share the window. Give it a second. There we go. And we are live. Okay, electrical lesson number 2. How to bring our... wait, can you guys see it? You guys can see it, right? Okay, electrical lesson number 2. How to bring our robot to life and submit to our robot overlords, but we don't talk about that. Okay, number 1, small review. Considering a few of you have not watched the video, I will just very not so briefly run through what I did last time. So don't disregard this question for now. If you do know the answer, that's pretty good. But in the circuit, we basically learned about the basis of our robot, so the base parts. So we know this is the battery, the heart of our circuit. This is the breaker, the sort of kill switch. It's really important just to make sure that if something does go wrong, we can turn off all the electricity in the robot, which is why it's connected right next to the battery. This is our power distribution panel, or PDP, and it's used to connect, all the other components of our robot, so all of the other electrical ones, such as the motors and a few other things. And so we talked about the breaker slots in between and everything else, and we also talked about these output points at the end that connect to our brainstem, which is our VRM, which connects to sensors and communication devices such as this radio bridge, and our central brain, or RoboRio. And so that's just kind of there, and they all connect to the PDP to get power. So we just gave our circuit power for now, but we didn't really connect anything that intricately, so we can't really do anything. It just sort of lights up and woohoo. So I'm hoping that that's a very bad explanation of what we went through last time in a very brief, short amount of time. But another question I would ask is, what is wrong with the circuit? Like, what parts are missing right now? There are quite a few more parts that we need to add to our robot to actually make it move and, have it work. So what do you guys think is missing from this robot? I'll speak out your answers because I don't think my desktop audio is being recorded. Yeah, so no functionality with the robot? Yeah, so what electrical parts would I need for that? Okay. Yeah, so motors and motor controllers, that's the main functionality bit of electricity. That's what most people see when they talk about it. And yeah, that's exactly what I'm missing, and that's the next step that we're going to cover. So there's a lot more that I'm missing, but we're going to cover that later. But for now, it's just the motor and the motor controllers that we're missing. And if you guys watch the videos, you'll know that that's kind of like the muscles of our robot. It's what lets us move things that the mechanical team has created. So let's get right into the news. Also, another thing that's wrong with it is that this Ethernet cable is not connected to the bridge, so you're not getting any communication here. But it is connected, it's just the software is dumb, so we'll go through that in our other point too. Let's continue. So, where do motors go? Especially in terms of our electrical circuit, like we know all this, but where exactly do the motors go? Do they connect here? Do they connect here? Do they connect here? Like we don't really know where that goes. So let's talk about where do motors go. There are two primary outputs of the motors themselves. So there's the inputs, not outputs. There's the power input and the control input. So to control the motor, we can use motor controllers. Again, we talked about that in the last one. So these can be inbuilt, like the Falcon 500, which has the motor controller and the motor in the same little package, which is really cool, really neat, and saves a lot of space, or external, like the Talon SRX. And so that's external, and we have to connect it to the PDP first, and then from the PDP we connect it to the motor. Again, if I'm talking alien language, I suggest you check out our previous video. Anyhow, the external motor controllers will connect to the PDP, so that's how they get power on one side, and then from the PDP they will connect to the motor. So it's like it takes in power from the PDP and then it connects to the motor, and there's some magic that happens inside of the motor controller that sort of tunes out how much power is going out. And so the Falcon 500s connect directly to the PDP because the motor controller is built on the inside. And then there's control, so we finally gave our motor power, but how do we control that power? And so we need to connect the controller, whether it's inside or outside, to our brain, which is our RoboRio. So again, going back to the diagram, this is our brain, our RoboRio, so we need to find a way to connect it to this somehow. And so this is so the brain can control how much power will go to the motor, right? So the brain is supposed to control, oh, I want to move this arm at about like 70% of full speed. Or I want to move this at 0% of full speed, which means it's just not moving at all, right? And so we need the brain to control exactly how much power will be going to our muscles, especially in the robot too. Like if you want the robot to stop driving, that means the drive motors will have to move at 0% capabilities or 0% speed. So that's sort of the two inputs that our motors need, and we will connect it somehow. So how motors are controlled? This is also a pretty common question that I get. Like, how do the motor controllers work? What is that magic step in between? And so information from the processor. This is a little bit of programming, so again, you might be a little bit unfamiliar with it, but just a very small excerpt. In programming, the speed of motors is sent as a decimal, ranging anywhere between -1.0 and 1.0. Can you guess how this is translated to what energy goes into the motor? Like, how do you turn this decimal into how much energy will be going to the motor? I'll speak out your answers if you have anything. If you don't have any answers, it's perfectly fine. Sure. So it does move like so the negative and the positive do impact the direction of the motor. And the reason why it does that is if you guys have ever played with motors, inversing the flow of electricity to it, so moving the negative end to the positive side and the positive end to the negative side, will actually reverse the direction of the motor because now it's going to go in the opposite direction because the magnet's on the inside. For that reason, if we reverse it, if we send a negative number, it's going to go in the opposite direction of if we send a positive number, right? So the negative and the positive controls the direction of the motor. Really, really well done. And so, are we going to guess that if we set it to 0, the motor is going to stop? Does that seem like a logical conclusion to make? Yeah, okay. And if we set it to 1, what do you think would happen? Yeah, so it's the maximum in each direction. And so let's get to it. Electrical processing. So the output of the PDP, so the output voltage, is actually multiplied by the decimal that we send. An easier way to envision it is that we send a percentage, right? So 1, or the number 1, is also equal to 100%. 0.5 equals 50%, right? So 50% of the power, 0.25 equals 25%, and so on and so forth, right? And so negative 0.75 would be negative 75%. And so that means that it will output the maximum possible energy at 1, right? So that means 100% of the energy will be sent out to the motor so it can spin, and then half the power will be sent out at 0.5, which is 50%, and negative speeds will move the motor in reverse. Obviously, you need to check which direction is forwards and backwards before you determine which is forward and reverse, because your motor doesn't really self-align. You kind of have to find that out yourself. Regardless, it's pretty cool, and that's kind of how we're going to send information from the processor to the motor so that it processes it and then moves it, right? So at 0, it's not going to 0% output, so it's just going to stop, not move it at all, and at 0, at whatever percent, we'll move at that percent speed. Just as a general rule of safety, I know you guys are not in programming, but it's just pretty important to know. We never really move our motors at 100% capabilities because that will burn them out really quickly, and motors cost quite a bit of money. So we always keep our maximum speed as like 0.7, and even that's stretching it sometimes because that sort of helps with the longevity of the motors. Pretty neat stuff. Okay, let's continue. So one way of sending information to our motor controllers, right? So sending this decimal to our motor controllers is called PWM. So I'll explain exactly what that stands for as we continue. So before we understand PWM, we actually need to understand digital versus analog signals. So digital signals are essentially either on or off, 0 or 1, active or not active, right? So it's kind of like a light switch. Your light switch is either on or it's off. There's no really real in between. And so yeah, this is great for light bulbs and other simple power usages, right? So you can, like your oven, you want to turn your oven on or off, or you want to turn just anything that turns on or off, right? So a switch, right? So it's really easy. It's way cheaper than the other alternative, which is analog, to implement, and it's also quite easy to get. It's literally just a switch, and within your circuit, it's also just a very simple switch. So yeah, it's just used for anything where it's only either on or off, and it's basically just a switch. And then analog signals are essentially varying amounts of power that can go anywhere from no power to full power output, which sounds a little bit similar. I wonder. And it's great for when you have signals that aren't just dependent on or off, right? So if you have something in between, I know I said oven before, but if you have like a temperature sensor, then your temperature sensor will send higher voltages depending on how much depending on how hot it is, basically, right? And light sensors or photoresistors would also use sort of the same logic. Depending on how bright it is, it would brighten up and send more energy, right? So it's just this is for use cases where you don't certainly have like an on or off, but there's sometimes an in between. So analog is pretty cool for that. And so, which type of signal would be better for controlling our motors? Just a question to you guys: which one do you think would fit better with this? Like, do you think analog signals would be better, or do you think digital signals would be better to control our motors or to send that information to our motors? Which one do you think would be better type of signal? I think my audio is working, right? It's a daunting yes in chat. Okay. Yeah, probably a question that's pretty out there, but if we go back here, we see that this can go from anywhere between no power, which we can consider to be 0% power, to full power output, which we can consider to be 100%. So this means that it can send signals in a range from 0 to 100%. So most people would assume that because it has that range and the capability to perform in that range, that it is that analog would be better in this situation. However, analog is not better in this, not better, but it's not what we use in the system. We actually use digital. And the way that we use digital is by using a special technique called PWM, or pulse width modulation, right? And so this is sort of modifying our digital signals by changing the speed at which the digital signals turn on and off, along with the pattern, right? So the pattern that it generates, sort of like Morse code, but this is a lot more intelligent and a lot faster than Morse code. It's how you turn it on and off, and using that pattern, you can process the digital signals, right? So it's basically you need to know the speed, and you need to know exactly when it's turning on and off. So once you get that pattern, you can process what the digital signal means. And so this is called a PWM signal, and it's used to send these -1 to 1 signals from the Roborio to the motor controller. So it's actually really intelligent. If you think of binaries is just zeros and ones. So if you have a certain speed, you can turn a switch on and off at the speeds of those zeros and ones, right? So if it's a 1, you turn it on. If it's a 0, you turn it off. And then the electrical unit can sort of process those zeros and ones and go like, oh, so this is a 0, this is a 0, this is a 1, and then it can sort of compile it into its own single number. So that's our pulse width modulation, or PWM system. How to connect? Not on the simulator, sadly, because there's an easier way to do it. It connects directly from the motor controller to the Roborio. And so I have a diagram on the next slide, just to sort of show off how that would work. Analog for control, digital for efficiency. Basically adjust the duty cycle of the square waves. For PWM, it could be better to show visual diagrams for those who'd be new. Maybe, I don't know. To be perfectly honest, I think it's relatively easy to just think of it as turning on and off like Morse code. If you're familiar with Morse code, this would make a lot of sense. It's sort of just turning it on and off at a certain speed to sort of decipher what's going on. And that's our pulse width modulation, PWM. And so it does connect directly from our motor controller to the Roborio, and I'll show you exactly how that works. So there's no connection diagram because it's really bad, but here we see our Roborio, so all the different ports that go from our Roborio. And on the side we have our PWM, so these are just PWM slots. They have 3 pins each. And on our motor controllers, we'll see that there's a 3-pin output on the side, so this is our PWM output. And so we connect the PWM output to one of these PWM slots, and once we connect it, it's sort of going to send information there. So in terms of decoding, what it means, the black is ground, the red is a 5-volt positive charge, and the white is sort of our input frequency, or it's our frequency essentially. And the reason why we put red and black there is sort of as ground line, so sort of this is no power and this is full power, and you should use these as the guidelines to determine exactly what's happening in the middle. Okay. I just thought that it would be easier explaining that way, but you guys can go with the technical terms too. I just prefer to explain it that way. Okay, let's continue. So that's our connection diagram. So the pros and cons of PWM. Pros is it's very simple to understand and use. You just literally plug in the wires over here, and you send the signal in your code, and it's done. It's not that difficult to understand. It's easy to track what connects where. So every single motor will have to connect directly to this PWM slot, right? That's why there are 10 different ones. And that just means it's like really easy. Oh, this motor connects to slot number 3. So maybe if this motor is not working, I just need to double check what's happening in slot number 3. But that also brings about a few other issues. An individual connection from each motor to the RoboRio is a con in my opinion, because that means that you're going to have a lot more wires, which will clutter everything up, and it's going to be a lot more difficult to cable manage, which is quite the bummer and not something you really want to go around. And only 10 PWM connections are possible on the RoboRio. You only have 10 over here, and that means that you can only really output to 10 different motors. Obviously, 10 motors is, most people would consider it to be more than enough, but it's not just motors. PWM is also used to control servos, which are, like smaller motors that don't require these larger things, and so servos run with their own inbuilt controller, and so you use the RoboRio to control these servos. Let's say you have a camera, then you can have a servo attached to the camera to sort of angle the camera as you need, and that would be connected to a PWM slot, right? So having only 10 limits what we can do, and that's why we sort of wanted to change our system to a different one, and that leads us to CAN, the better version, except it's very far away from PWM in terms of understanding exactly how it works. It's less raw, more higher level and abstract. So let's get into it. Okay, network of wires, a lot of text. Connecting elements. So CAN is essentially a networking system that uses multiple different nodes. If you're in computer science at all, that would make some sense, but if you're not, then it makes no sense. Each node is essentially a part of our circuit that is controlled, right? And the start is our controller. And so by stuff that is controlled, I mean our motor controllers, those are controlled, or the Falcon 500s themselves, and the PDP, that also is controlled to a certain extent, and other aspects of our circuit that are directly controlled by the brain. And so they're all called nodes, and they're all directly connected using this CAN system. Each node, the nodes each have their own address. And so what that means is each node has sort of, oh yeah, this is my name, right? And that's essentially what they identify as. So when a signal is being sent from the CAN, or signal is being sent into the CAN, it'll be sent from the first wire, which is the start of our controller, all the way until the end, until the address matches and the instructions are sent, right? So once they sort of get their address and they're like, oh yeah, this is my address, then they'll sort of take in the instructions as well, and then they'll emulate it, right? So an easy way to sort of imagine it is emails. And so the RoboRio is pretty dumb, and it sends an email to all the CAN devices. Imagine like a CC email to all CAN devices. Then the CAN devices will only open the email if their name is in the subject of the email, because they are very busy. Very busy people, so only if they see their name will they open it, and their name has to pop up in the subject, right? So let's say that there's a motor, and the motor's name is Jim. Then only if Jim sees his name in the subject of the email will Jim actually do his job. And so in the same way, once they find and open an email, so it has their name in the subject, they will get their instructions. So the instructions are in the body of the email, right? So the content that we send. And then once they get their instructions, they'll do exactly what the instructions say, which can be anything like change the output to negative 0.7, etc. And there are a few other conventions that go around, but this is just the general way that CAN sort of communicates throughout the system. It's a lot higher level, so we're not exactly talking in the specifics of, is this digital or is this analog, but it's a lot higher level, so this is definitely a more advanced system. But it's very simplified, especially in FRC circuits, so I wouldn't really worry about it at all. Let's continue. Wiring CAN is pretty easy, so it all starts from the RoboRio. If we go back to our, here it is, we'll see that there's a CAN output over here, and so from the CAN output, you will get these two green and yellow wires. They're the CAN ones, they're pretty twisted, and you send them to the other parts of your circuit. So you'll notice that the RoboRio only has 2, but all other parts of your circuit will typically have 4, and the reason why they have 4 is you connect 2 in on one side, and they go out through the other, right? And so it's basically forming like a huge network of them, and you put 2 in on one side, they output through the next, and they continue to the next one. So it's all connected to the RoboRio by the end of it, but they're just daisy chaining off of each other. And we have more over here. So this is the PCM, the pneumatics control module. Obviously, we're not using that this year, or virtually. I mean, we might do it later, but just not yet. And so this has 4, so you connect 2 here, and then the other 2 you connect out. And this is the PDP, so it connects into the PDP. Notice how the PDP also has 4, so then they go there, and then they get outputted through the other one. Does everything make sense with the CAN bus system so far? Is anyone confused? If you're confused, just let me know, because I'm 100% open to explaining it in more detail. Yeah, sure. So I'll actually get in. I think I explained that in the pros and cons section, but a very generalized benefit is you know how there are only 10 possible connections on the PWM? The actual purpose of CAN is it's a modular system. So what that means is you can very easily take out the wires of one thing in the middle. Yeah, more ports. You can connect it to literally anything that's a CAN device. You can essentially connect as many as you want, right? You just connect more wires to it, and it also means it's very easy to remove, and only one wire goes throughout the system. So I'll explain that in the pros and cons section over here, and here we are. So pros and cons, it's a globally recognized system. So CAN is actually used a lot in what is it? The automotive industry. So they use it for like any electrical components within your car. Typically have a lot beefier, albeit, but still a CAN system that runs throughout it. Only one wire or wires like wire kind of system is needed throughout the system. So I said system twice. Only one wire is needed throughout the system, and so what that means is while these are all like different wires, so it goes from so there's one wire that goes from the CAN on the RoboRio to the PCM, and then another wire that goes from here. It's all technically one wire because it's just connected in different ways, but it all acts like one wire in the end of it, right? It's like kind of zip tying a couple of wires together and spreading it out. So it's the same way. It's also more modular with the instructions, right? So in terms of PWM, you can only realistically send whatever it was programmed to do. And if you want to change it, you'll have to change every single motor. But for the instructions on the CAN, you just have to change. You just have to say, oh, I want to add a new type of instruction. It's going to be in this type of data. This is more like for the programmers, but it's a lot better for them. And new devices can be added really easily. You just sort of like, oh, I want to add a new device to this. Then I just take two wires out of the CAN on the PDP and I connect it to the other one, and I continue and I continue and I continue, and you can sort of add as many as you need, which is a lot better than the PWM in my opinion. And we use CAN typically in FRC. If you don't use CAN by 2021, it was introduced in 2015. So if you don't use CAN by 2021, it's going to be pretty embarrassing. But it is what it is. So the cons are, it can be hard to understand at times. Like some people don't really understand, oh, so this is CAN. Why are there like 4 ports on this one and 2 on this one? And where do I connect the red and yellow? Not red, it's green and yellow. What direction do they go in and blah, 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 right? But it is pretty difficult to understand. It comes with experience. And you need CAN-enabled electronics, right? So remember what I said about the servos? Servos have their own inbuilt controller. So servos typically don't have CAN because that costs a lot of money. Especially like a CAN controller within a servo. So you typically need CAN-enabled electronics, which most FRC motor controllers, not most, yeah, most FRC motor controllers are in CAN-enabled, which is great news. So let's get right into opening our simulation software. Hoorah! So I'm going to start presenting my screen. I'm going to start presenting the simulation software and pray that my computer doesn't break, which is, that's going to be hard. Okay, there we go. Yes, so let me I really do apologize for it. Armand and I will work on making it better. It's just it's what it's student made. It's not a good excuse, but it is student made. So there is that. Okay, let's get right into it. So I actually saved our circuit from last time, but because a couple of you didn't attend the first session, I'll actually build it from the start. Very simplified again, but so this is our software top bar. I hope you guys remember. Quit, save, pretty self-explanatory. Help, give some instructions, options, just options about the styling, like the grid and stuff. Clear, we'll clear our circuit. Toggle panel, we'll remove the sort of UI thing just to make it easy to present. And simulate, we'll simulate our circuit. So our circuit always starts with the PDP because that's where all the connections will be connected to. So we put that guy right over here. And then we need our breaker because we need to make sure that we can turn off all our electronics if need be. Then we can connect our battery, right? So battery, you double click on an end to make a wire out of it, and you click to connect it. And then you move these and you click to sort of place them. Oh yeah, okay, whatever, just place yourself here. And so I double click here, and then I connect this over here, and then I double click here, and then I connect this over here. Okay, perfect. It looks really ugly, but I really just want to get through this without crashing my laptop, please. So I'm going to very quickly just try to wire everything up without it breaking apart. And then we connect our VRM. So our VRM is like our brainstem. It's where we connect our sensors and communication modules. So it connects to these top 4 sections right here because it says, VBAT for VRM. and PCM. So PCM is just like the VRM, but it's for pneumatics. And so we connect these guys over. So, you know, double click and click to finish. They format pretty well, I think, in general. And then we want our, what's it called? Radio. We want a radio too. So we got our radio. Put that guy over here. And then we want to connect our robo reel as well. So double click on these ends to sort of get there. And then we connect these to the bottom ones because that's where it goes, because it doesn't need as much amperage in terms of the breaker. And connect that guy over here. Okay, there we go. That's great. And finally, we need to connect our radio to our VRM. So double click this to sort of get the polarity, double click this to get the Ethernet. Watch as the Ethernet doesn't connect. This is still connected. It's another bug in it. But if you click the wire, it'll show connection 1 to the radio, connection 2 to the robo reel. That means it's connected. It's really dumb. And you connect this one to 12 volts, 2 amps. So I'm just going to zoom in a little bit. I want to connect this to 12 volts and 2 amps as well. Okay, again, very ugly circuit, but it works, I think. Let me simulate it. Okay, everything works. Next, we're going to simulate working with our not Talons, we're going to be working with Falcons because that's probably what we're going to buy. Remember, Falcons are much easier because they you don't have to have a motor controller, they connect pretty easily. So we're going to put that guy right there. And so before we get started with the rest of it, we actually need to connect our CAN. So we need to start our CAN over here, and then we need to connect it to our Talon, and finally we can end it off with the PDP. I think it's a pretty solid way of doing it. So let's start off our CAN over here. So we have our green and our yellow, and then let's open up these ports. Let's see which ones they are. So we have our green and our yellow there, right? So we want to connect our yellow. Oh, connection is already taken. Okay, so we want to connect our yellow there. Okay, there we go. And boom. And format this. They should be twisted in real life, ideally, but these are not twisted, so all is well. Remember, just connect onto the wire, and then move the wire ending accordingly. Oh wow, yeah, my computer is heating up. Oh Jesus. Please don't break. See, I twisted them. Wow, that's great. Great practicality. And then we want to connect the other side of our CAN to the PDP. So our PDP is going to be the last connection. So we're going to double click here to open up the wires. Okay, there we go. And we're going to double click here to open up our wires. These ones actually have the icons on them, so it's a lot easier, but you gotta make do with what you gotta make do with. And you connect this one to this green edge, and you know, move wherever. I think that was a good position. And then we can move this edge. Let's just say like over here or something. I don't know. I'm just trying to get this done without my laptop breaking. Let me know if you guys are actually opening up the simulation software or if you are struggling somehow. Okay, there we go. This one's a lot neater. Why is this one on the top? It's just dumb. Okay. So, do you guys think that this circuit is done? Do you think that we've connected our CAN to everything and that everything is good? It is available on Linux. It's on their download page. You have to download .jar, so you'd probably need to get OpenJDK. So do you guys think that this circuit is done? I don't know if it's sharing, but it should be. Yeah, but do you think this would work? If I turn it on, do you think it would work? This is the Falcon 500, which means that the motor controller is built in. Okay, so let's try that theory. It's actually not connected to the PDP at all. Oh my god, who could have imagined it? And so what we need to do is we actually need to connect the motor to the PDP. And so the way we do that is by moving these guys. And so these guys connect directly to, I think, right here. There we go. And so they're a little bit hidden because they're the same color as that, but you know, it's relatively visible. So let's just say we move this over here and we keep that black cable over there. Now if we simulate it, you'll see that it is can't change much, must reach PCM. Okay. Well, I didn't realize that this was picky about that. No. It's just that you need the PC. Okay, wait. Hold up. Let me explain this. Which is pretty weird. Okay, so in your circuit, there are a few components that are directly controlled by the CAN that are very essential parts of the circuit, right? So remember when I was saying that the PCM or the pneumatics control module is something that's not important to us because we're not working with pneumatics yet? We still need to connect the pneumatics through CAN. And the reason why we need to do that is to essentially is to verify that the circuit is working. So the CAN must be attached or the PCM must be attached to the CAN somehow. And so we're just going to put it right at the end, right next to the PDP. And so we're going to do that by using our, where is it? PCM. So just add in a PCM. We're not actually going to use a PCM. We're just connecting the CAN to it. So these guys. And then connect them to the yellow endings over here. Or the yellow or green endings, whichever one is most relevant. There we go. And now, if we simulate it, you'll see that the PCM is not connected to the PDP. Can't chain improperly wired at Falcon 1. Ah, this is very picky about things. Okay, so we're gonna disconnect this CAN chain over here. Oh no, did it crash? Oh, it didn't crash. Okay, thank the gods. No, don't crash, sir. Okay, yeah. No. Okay. Can I undo that? I can undo that. Well, that's great. That's great. That's golden. Thank you, Mister. Okay. Thank you. Thank you so much for that. The software is great. I don't hate the software. Who hates the software? Why would you ever hate this software? I don't know a single person who'd ever hate this software. Nuh-uh, no siree. Okay, let's get this started. So, I think we need to connect the PCM first. And probably need to connect the PCM first because the PCM is one of the essential components. And so it's kind of like, imagine a car. It's sort of like a safety system. And if you have a car that has an electronic gearbox and the gearbox is just not connected, it's a good safety system to make sure that nothing else works if the gearbox is not connected, because that means that nothing will blow up. And you know, by blow up, I mean like the driver can't get in an accident, because if it's not connected, that means that the gearbox won't move and the car will, you know, be stuck at one gear and a few things will not work. So for that reason, we typically just keep these safety components always connected. So I'm gonna connect this one over here. Jesus, you know what a good spring break project would be? Fixing this. Oh my god. It's okay, I'll fix it someday. Big emphasis on someday. Okay, maybe I just keep this one like here. Okay, you know what? I think that's good. Next, we want to connect it to our PDP, because our PDP is another essential one. So we want to make sure that these are 0 and 1. So they're the first two connections in our entire CAN circuit. So we can do that by just double clicking here and connecting our wires. Okay, perfect. I think that's good. Now, I think we can finally add our Falcon 500. So if we simulate this, oh, they're not connected to the PDP. Oh, yeah, you guys are not connected to the PDP anymore. Oh my god, how could I forget? Oh no, don't move that, please. Is everything working for you guys, or are you just not using the software? You could just not use it. I think that's good too. Node connection. Power connection for the motor. Yeah, so we were missing the power connection for the motor. Nice job noticing, Manjot, I think. That's your name, right? MV, the one with the butterfly. That's you. I miss you. Okay. Cool. Now we're going to connect these guys to our respective terminals. Okay. Now it should all be green. Oh my god, PCM is not connected to PP. Thank you. I'll get that done. Okay, so I think the V in, okay, so this is where we connect it. So where it says V in, voltage ins, right? So that's where we want to connect our energy. So remember, the VRM and the PCM are connected to these top two green slots. So we're going to get the second green slot open, and we're going to connect it from there. Right, so get these two guys out. Okay, and connect it. So this one goes to the red port, and this one goes to the black port. Okay, now if we simulate, we see that everything is good, everything is running, and nothing has blown up so far. Is anyone at this step? It's an important question to be asking. Or are you guys just not opening up the software? Because I fully do expect it to break your laptops. Please don't open up the software if you think that it doesn't work well on your laptop. I think the .jar one works though, so I would suggest trying that out. Let's do a little circuit review while we're at it, because I know we're all pretty confused because I changed quite a few things from my original plans. I actually didn't test this yet, but that was interesting. So, as always, our circuit starts and ends at the battery, right? So all energy is sent out from the battery, and all energy comes back to the battery. So this is our battery, and let's follow the energy sort of going on the red line. So the energy goes up into our breaker, right? So breaker for safety, and from the breaker it goes to our PDP. Pretty simple. And so we'll talk about the CAN connections later, but from the PDP, we will connect power on one side to this VRM, right? And so this VRM is important because it's sort of the brainstem. We connect our sensors here and our communication devices. So you could connect cameras here, you could connect gyroscopes if they need power. Anything that needs power, you connect it over here. Or small devices that need power, right? And then we also sent some power out to this PCM. And so this PCM is for pneumatic devices. Pneumatics are essentially pressure-based devices, so hydraulic pumps and the such. We haven't learned how to use them, so don't worry about it. This is just a very important part for the CAN connection, which again I will get to. So power, we have some power that goes to this PCM. Next we have some power that goes to our brain, our RoboRio. And so when it goes to the RoboRio, it powers the RoboRio, and by powering the RoboRio, it also powers this CAN connection. Oh wait, no, before we get there, we have one more power connection. So from the VRM, there's also another positive line that's sent out, and it goes to our radio. So this powers our radio, and the radio is how we connect our circuit, or our robot circuit, with our laptop. So when it's connected to our laptop, we can then use it to control the circuit using a controller, something that's connected to the laptop and our driver station. Does that sound good in terms of the power so far? I'm going to get a quick drink of water. Yes. Thank you, Vivek. I don't know if that was very convincing. Yes. Oh, we have a yep as well. Okay. That was some good water. Okay, yeah. I've gotten 3 yeses, so I'm going to assume that's a majority of you, considering no one else types in chat. I apologize. You guys are important too, okay? Just make sure you communicate in chat. Why are there 3 Adis? Adityas, not Adis. I keep getting names confused. Okay, finally, the other miscellaneous connection is from our radio to our RoboRio, which is just this Ethernet port, which is connecting them, using Ethernet. So just a basic Wi-Fi connection from the radio to our RoboRio. Okay, next, moving on. By powering the RoboRio, we power on this CAN connection. And so this CAN connection is now powered and sending signals. And so by sending signals, it's going to connect to our first device, which is our PCM. And so the reason why we connect our PCM as our first device is pretty weird, but it's basically a safety measure, because we always want to make sure that the PCM is there and connected to make sure that if we did have pneumatics in our system, that they are controlled, because pneumatics are very dangerous things, and if they aren't controlled, then you can have like pressurized cans that shoot out, which can cause a lot of damage to some students. So we always want to make sure that when we turn our robot on, all of the components that have dangerous things connected to them are connected to CAN somehow. So as a safety measure, this PCM has to be the first thing we connect to our CAN. So by the first thing I mean is from our RoboRio, it's the first object we connect to our CAN. Does that make sense to you guys? Okay, thank you, Jasmine, for saying something. Next, from our PCM, so it goes into the PCM, right? So the CAN goes in, and then it also goes out. That's why this one has 4, because it's supposed to be like a part of the bridge. So then it connects to the next thing, and the next thing in our system is our PDP. And so our PDP always has to be connected second, and the reason why it always has to be connected second is the same thing. It's a safety measure. So we want to make sure that our PDP is controlled by our RoboRio, and that if anything does go wrong, that our RoboRio can send signals to the PDP to turn it off or to change something, right? So it's always going to be in position 2. And by position 2, I mean it's the second device connected from the RoboRio's initial CAN connection. So RoboRio is device 0, This PCM is device 1. Actually, I think PCM is whatever, so no point. And then this is device 2. So this PDP is device 2. And then from device 2 onwards, we can connect whatever we want, however we want it, right? And so we're going to connect our 2 different types of motors or motor controllers to it just to sort of show off how it works. So we're going to connect our Talon. So this is what we used last year. So this is what I had to suffer or enjoy with. It was pretty good, to be perfectly honest. I don't know why I hate it so much, but I do. I have a deep-seated hatred for it. Okay, so the positive, so the red and the black are supposed to connect to our PDP, and then the green and the white are supposed to connect to our motor, which I will attach later. So we're going to rotate this guy. Okay, and I think this is 12 gauge. This is 12 gauge. This is also 12 gauge. I think we connect this one here. Yeah, there we go. We connect it to the big slots because this is a resource-intensive piece. Great, motors use a lot of energy. Okay, so we're going to connect that over there. Great, we have our Talon SRX connected. Next, we want to connect our CAN. So we can do that by just double-clicking here, and then we connect it to our PDP. Oh, no, I forgot to actually click the thing. No, no, friend, you are deleted. So we go from here, and we clip onto here, and then we go from here, and we clip onto here. So what device number is this CAN? Or is this Talon SRX device? Can you guys give me a device number? 3. Yeah, it is device number 3. Hoorah, nice on getting it. And so now this is connected to our third slot, and if we want to connect more devices, they have to connect from out of this Talon SRX. So now let's try to simulate our circuit, and we'll see that CAN chain must reach PCM. Is the PCM supposed to be the last thing? CAN chain ends at Talon 1. Supposed to reach the PCM. Is it supposed to end at the PCM? Did I get everything wrong? Maybe the PCM has to be the last thing. It's such an interesting point to make. Okay, let's do that then. Let's connect the PCM as the last thing. Again, safety measures, it might be easier to check if something is the last one. I don't know. I have no idea. Safety measures are completely overrated. Oh, no. Yeah, okay, there we go. And you connect to this one. Aha, why do I have to zoom out so much? The software is my best friend. Okay, let's simulate it now. Okay, so that works. That connects there. Maybe it just doesn't have to reach the PCM. Maybe the PCM just doesn't matter. Maybe it just doesn't matter. Oh, no, it does matter. CAN chain must reach PCM. Okay, so let's connect this guy. Let's put him up here. So we're going to stop. And let's try to connect the CAN chain there. CAN chain should reach RoboRio. It starts from the Robo. Oh my god, okay. Well, I guess it ends at the RoboRio then. Oh, actually, that's smart. Yeah, it does end at the RoboRio. Oh my god. Okay, I'm dumb. Sorry, guys. I think it starts at the PDP. Okay. Okay. I guess we have a second RoboRio. I have a deep-seated hatred for the software at this point, but it's okay. It's okay. You guys are okay with the software, right? You're not freaking out like me? You might be. In which case, I do feel bad for you. I'm freaking out too. We can be freak out buddies together. Okay. Oh my god. I'm finally connected. Now this one is supposed to connect to... This one says yellow. This one says... Okay, there we go. This one's supposed to connect there. Then this one's supposed to connect here. And now, if we simulate it, the radio is not connected to... Okay, thank you, radio. Can you please connect to the... Oh, it finally worked! The Ethernet finally worked! Oh my god, it's beautiful. See, guys, the trick is to keep on deleting things, and then everything works. Yeah, we're freak out buddies together, my friends. Freak out buddies together. For the motor controller? Okay, yeah, so this is something I can explain. So our CAN is actually supposed to start at or it's supposed to start at our PDP, I think, for some reason. So PDP is device 0. I don't think there's a set starting position, but it should always end with the PCM, and the PDP should always be connected. So I think it's supposed to be connected at number 0. So from here, these are the output cables, right? So this is outputting, and then it goes into our motor controller. So now the connection to our motor controller is made. And then for our motor controller, we want to connect the next device. So CAN is or this PDP is device 0, motor controller is device 1, and then from motor controller, this PCM is device 2, or this PCM always has to be the last device, and the last device will connect directly to our RoboRio. And so the reason why we have 2 here is because this is the input, so this is sending the signal into the SRX, and then from the SRX we want to connect the signal to whatever other devices we have. Does that make sense? Oh yeah, sure. So the PDP, despite popular belief, is actually intelligently controlled from the RoboRio, and the reason why it does that is because we want to make sure that the number of the power outage, not the power outage, the power outputs are recorded, right? So within the PDP, it has useful sensor information like how much energy is being used and blah blah blah. So we want the RoboRio to get this information so that it can intelligently process other things. Does that make sense? Yeah, for each single thing. Yeah, that's why it has 4. Okay, sounds good. Sounds good. So yeah, we always want to make sure that the PCM is the last one. I think for some reason, which is incredibly weird to me, but safety measures, I guess. So now that we have one of our motor controllers connected, we actually have to connect a motor to it. So the motors that we're going to be using here on the simulator, there's only one, and it's the 775, which is a eventful motor. So I think is this one M1? I think this one goes here. I actually don't know. Maybe this one goes here. Maybe this one goes here. Let's try it. Oh yeah. Okay. Wait. So let's disconnect this. So I think this one goes here. I think this one might go here. Okay. There. The motor is properly connected. And now we need to finish the PCM chain. So we actually want to add a Falcon as well. So before we end the chain, we want to connect another motor to the chain. So that's going to be our Falcon. Remember, we want to connect. Oh, wow! Don't break apart on me, friend. Come on, let's go. So we're going to connect the black cable here. That's our negative power, and our red cable over here. That's our positive power, right? And so I'm just going to move that like this. It's going to look real weird. And then we want to input one side, right? So we take these out, and we take these out, and we just sort of connect them in. Right. So we take this. And we connect it here. And we connect this here. No, oh my god, no, stop. Just, okay, thank you. That's clean enough. And finally, we have connected our Falcon 500. Notice how we didn't have to actually connect a motor to it because the motor is inbuilt. We just have to output these ones to the PCM. So, by the name of God, we are going to get this done. And as well, if we don't, I'm going to blow this up. Okay, everything is connected now. We have 2 motors connected. It's typically a lot easier in real life, I'll say that. You don't have to deal with the weird wires. It's a lot easier, but everything is green. That's always a good sight for sore eyes. So yeah, we'll see that we connected both of our motors and they work really well and they can be controlled directly by our friend, the RoboRio. So now that we have gotten that and it doesn't explode, I'm going to save it somewhere. Okay, let's just go to download slash motor.tk, I think is the output. Okay, well I put that in my downloads folder for some reason, so I guess that's good news. Is it just me or is everyone lagging? I think it might be me that's lagging. My Wi-Fi was really bad yesterday. Oh, it could be. Do you have the software open? It could be the software blowing things up. So do be careful with that. Anyhow, I'm going to quit the software now. I think I have it saved. Oh, I'll upload the file. I'll upload the file, the saved one. I'll upload it to the Google Classroom so you guys can open it. Yeah. Yeah, don't worry, don't worry. So I'm gonna end the meeting now. So for those on the recording, I'm not gonna end the meeting. I'm gonna end the recording. So for those on the recording, I hope you guys enjoyed. Again, the file will be posted. I think it's also going to be in the description for the YouTube video, so you can access it there. And have fun. Bye. Okay. Well, I'm not actually leaving you guys though. That's it.